Question 1. At time t seconds, where t is greater than 0, a particle p has velocity v meters per second, where v is equal to 3t squared I minus 6t to the power half j. Part A, find the speed of p at time t equals 2 seconds. Well, we've got velocity as a vector, so let's substitute t is equal to 2 to find out what we get. So when t is equal to 2, we can substitute it into our velocity vector. So we get 3 times 4 lots of I minus 6 root 2j. This gives us a velocity vector of 12i minus 6 root 2j. Now we want the speed. Velocity is not speed. The magnitude of velocity is speed. So we need to find the magnitude of our vector v, which is the square root of our I component squared plus our j component squared. This is root 216, or 6 root 6 meters per second. Part B, we're trying to find an expression in terms of t, I and j for the acceleration of p at time t seconds, where t is greater than 0. This is where we need to remember what our integration and differentiation do to our velocity vector. Now, in this case, we want acceleration. Acceleration is the change of velocity over time, so we need to differentiate our velocity vector. So our acceleration being the derivative of velocity, differentiating, multiply by the power, and then subtract 1 from the power, gives us 6ti. A half times 6 is 3, so we have negative 3t to the power minus a half. A half take away 1 is minus a half. So here is our acceleration in terms of t, I and j. Part C, at time t equals 4 seconds, the position vector of p is I minus 4j. Find the position vector of p at time t equals 1. Now, velocity is the change of displacement over time. So in order to get displacement, we need to integrate our velocity. Typically, r is used for our position vectors. So r is going to be the integral of our velocity vector with respect to t. Integrating, we increase the power by 1 and then divide by the new power. So we get r is equal to t cubed I minus 4 lots of t to the power 3 over 2j, not forgetting our plus c constant. Now we have been given boundary conditions in the question. We're told when t is 4, the position vector is I minus 4j. We can use this information to write this following equation. Our displacement vector of r is I minus 4j when t is 4. So substituting t is 4 and our position vector of I minus 4j, we can rearrange this to find our constant. Now that we have our constant, we have our more generalized form of our position vector. This is taking our integrated vector and now putting in our constant. Now we have this position vector, we can substitute in the time we want. We're told we need to find the position vector after 1 second. So when t is 1, substituting in, we get r is equal to negative 62i plus 24j.